What if everything is an illusion? Close your eyes. Imagine standing in front of a vast wall perfectly black, smooth and infinite. You reach out your hand, but instead of touching substance, it dissolves into light. Nothing is solid. Nothing is fixed. What if everything, your body, your memories, even space and time, isn't as real as it seems? What if the universe itself is a projection? This isn't science fiction. It's one of the boldest, most mind-bending ideas in theoretical physics today, the holographic principle. The suggestion that our entire 3D universe might be a shadow, a projection of information encoded on a distant 2D surface. In this documentary, we'll journey into black holes, quantum information, string theory, and the boundaries of space and time to uncover whether reality is truly holographic. The origin of a radical idea. In the 1970s, a Dutch physicist named Gerard T. Hooft was studying black holes and quantum gravity when he made an astonishing proposal. What if all the information contained in a region of space could be described by information on its boundary? Later, the idea was expanded by Leonard Susskind, who connected it to string theory. Susskind argued that just as a hologram stores a 3D image in a 2D format, so too could the universe store all its physical information on a 2D surface, and yet create the illusion of 3D reality. They weren't alone. The proposal was deeply rooted in attempts to solve one of the greatest paradoxes in physics, the black hole information paradox. Black holes, according to general relativity, seem to destroy everything that falls into them, including information. But in quantum mechanics, information can't be destroyed. Something had to give. The solution? Information may never really be lost inside a black hole, because it could be encoded on its surface. That's where the holographic principle was born. Black holes and the edge of reality. Black holes are not just cosmic monsters. They are laboratories of reality. In 1974, Stephen Hawking shocked the world by showing that black holes are not completely black. They emit radiation now known as Hawking radiation due to quantum effects near the event horizon. Over time, this radiation can cause the black hole to vaporize. But if the black hole disappears, what happens to the information about the matter that went into it? If it disappears completely, it violates quantum theory. If it persists, where is it stored? Hawking, Susskind, and others argued vehemently. A solution began to emerge. Information about what falls into a black hole is stored not in its interior, but on the event horizon, the two-dimensional surface. This led to an incredible realization. Perhaps the entire universe works the same way. Just as a black hole encodes its contents on its surface, the cosmos may be the same. The mathematics of holography. In 1997, physicist Juan Maldacena made a stunning breakthrough. He proposed a duality between two radically different theories. Gravity theory in 5D spacetime including our usual dimensions, quantum field theory without gravity at the 4D boundary of this space. This became known as the ADS or CF correspondence, an exact mathematical realization of the holographic principle, although the particular geometry anti-de Sitter space does not describe our universe. the universe as information. At the heart of the holographic principle is one strange idea. Information is more fundamental than matter. Everything we see around us may be the result of bits, tiny units of quantum information interacting, processing, and evolving. This isn't just theory. Scientists like Seth Lloyd and John Archibald Wheeler have proposed that the universe is fundamentally a quantum computer processing information at the smallest scales. Wheeler's famous phrase, "it from bit," suggests that every particle, every field, and every interaction arises from binary yes-no choices from logic, not substance. Your body, your thoughts, the sun, the galaxies all might be emergent phenomena built from pure information, unfolding on a lower dimensional surface. Could we ever prove it? If the holographic principle is true, can we test it? Physicists are trying. Some look at cosmic microwave background data, searching for statistical fingerprints of a holographic geometry. Others examine quantum entanglement and the structure of spacetime itself. Experiments like the Fermilab holometer aim to detect holographic noise, tiny jitters in spacetime that might reveal its digital nature. Far, no conclusive evidence, but hints keep coming. Theories involving emergent gravity, tensor networks, and quantum error correction are painting a picture of spacetime as an illusion, built from deeper rules. If true, it would mean that you are not truly in space, but rather, your entire reality is a projection from a distant, invisible boundary. Consciousness and the hologram. Some thinkers go even further. Could consciousness itself be a holographic phenomenon? Neuroscientist Carl Pribram and physicist David Bohm suggested that the brain doesn't store information like a computer, but like a hologram, distributed, overlapping, resilient. Perhaps reality and mind are both projections, not separate, but reflections of deeper structures. Quantum consciousness remains speculative, but one thing is clear. The holographic principle forces us to rethink what we mean by real. Maybe the boundary between mind and universe is itself an illusion. What does it all mean? If the holographic universe is real, space is not what we think it is. Time may be an emergent illusion. Our world is deeply connected to an invisible boundary we cannot see. This isn't just theory. It's a call to rethink physics, philosophy, and perception itself. We may live inside a cosmic illusion, but that illusion is governed by rules we're beginning to decode. We are shadows of code. Awakening. The wall and the light. Remember that wall of blackness at the beginning? Maybe it's real. Maybe we're seeing its projection. Maybe we've spent millennia staring at the shadows on the wall, unaware that reality lies not within the cave, but on the wall itself. The holographic principle doesn't diminish the universe. It reveals how much more there is to understand, and perhaps how deeply we are already a part of it. If you found this journey fascinating, subscribe for more mind-expanding cosmic explorations.